I am Adam from Analytics team, and today I will show you how to solve problem A. This problem is rather easy, but statement is a little bit complicated, so it might intimidate some participants. So this problem, it was about some card trick. So initially it has a grid of cards. Here's an example 4x3, and as it stated in a statement, with the example of parameter p equal 2, which is the most important parameter for this magic trick. The host of the game just asks the spectator to choose where his card located, in which column. For example, here, let's take the third column. And then he reshuffles the cards in the way that he sorts them row by row and then places this selected row in the specific order according to the parameter p. So let's rearrange it. As stated in the statements, all other cards which once happen in not selected row are not important, so I mark them as the x's, and our important row I will leave as it is. So the question of the problem was to find such p that for any guessed card it ends up in some fixed location, and additional requirement is that this location should be as close to the center as possible. So to do this, we will just try all the p's. However, just simulating everything as stated in the statements, it could be a little bit too slow, so some observation is required. So first, let's notice that first, initially, our guessed card can be in any row. And after we did the first iteration, it only can be in the second and third row. So after each iteration, the rows where this selected card can be is always a range of rows, and this range of rows is always squeezing. So after several iterations, it always will be an segment of rows, LR, and we can just iterate over until these two bounds will become equal. So the only thing that needs to be checked is whether this range will be squeezed into one row. So sometimes it can be always cycled at the two rows, so this case should be checked. And the overall solution should be like we try all p's from 1 to number of columns and just check them. Check if it squeezes to one row, and if it is, we'll see what is the location of this card and just check whether it is the best result found. That's it.